So if you have an app out in the App Store, likely when you go to release an update for it, you've seen this button, the release this version. And with the Apple App Store, once you click this button, there's no going back. Your update is released, and that's it. Likely this makes you very nervous. It makes me very nervous when I'm about to click this button. So hi, I'm Michael, and what I'm going to try to do today is help you be a bit less nervous when you have to release an app update. So first of all, I want to get a sense of the testing experience in this room. How many of you have unit tests in your current app? Okay, that's quite a few people. What about UI tests? Okay, quite a few less. How many of you wish you had more tests and better tests? Yeah, there we go. So my pitch to you is pretty simple today. What I'm going to show you through my talk is how you can construct a test framework and really get a great set of end-to-end UI tests. And what ends up happening is once you have more tests, you will be able to have more frequent app updates. And you'll be able to have less stress when you click this button to release your update. And now I came to work with UI tests in a very roundabout way. And to be honest, for most of my iOS career, I used to be completely terrible at testing. So let me just show you through a few of the apps that I built. So this was the first app that I ever built. This was right about when the iOS SDK came out. It was this database client that synced to a desktop database. As you can see, the design is iOS 2. And it had effectively no tests. There were a few unit tests for this calculation engine in it, but no testing otherwise. And every time it would release, I would be terrified that there was some critical bug that someone would experience. And once in a while, that would happen. And I had to beg Apple for expedited reviews. Back then, reviews took 2-3 weeks sometimes. And if you ever had to beg Apple for an expedited app review, it's not fun. It was awful. But being a small developer, I didn't really have much choice. So no testing, fine, that was life. So a few years go by, and I'm working with a few friends on this next app. There's actually two apps. There's an iPhone app and an iPad app. And what this app did, it sent multi-touch gestures from your mobile device to a desktop 3D CAD software. So this allowed you to control your CAD applications, kind of manipulate pan, zoom, orbit. It was a fun little app that engineers would use. But to test it, you had to connect to a computer to really get a full test of it. And being a small team and trying to release an app, we also didn't really put any testing in place. But this app did get some traction when we released it. And we used that traction to apply to Y Combinator. And Y Combinator, it's a startup incubator in California. Dropbox, Airbnb, many other companies came out of it. So based on this traction, we applied to it, and we were very fortunate to get into Y Combinator. So this app kind of was abandoned. Also, no tests. But once again, that was fine. So during the program, we ended up pivoting to the next major app I worked on, which is Couple. So as Vishnu already said, Couple is an app for you if you're in a relationship. So it's a messaging app with your significant other. It's a more fun way to message. It has some practical things like to-do lists, but it's also just more fun. It's private. It's one conversation, one app. And when we released this app, it went viral. We had hundreds of thousands of downloads within a week. And we used that kind of opportunity to raise some money. So we went to investors, and we had a couple of VCs invest a few $1 million in this idea to grow it into a startup. But of course, you take on money, and you have to ship your app faster. You have to iterate. You have to move fast. That's really the only thing that a startup has. So in our case, we focused on trying to ship fast. And that meant just developing more features, always working on product. So we didn't take the time to stop and really think about testing. And the tools back then weren't that great. This was back in 2012. So we had a lot of delayed releases, a lot of last-minute bugs that we had to fix. And looking back at it, to be honest, having no good end-to-end tests in this app really hurt our development speed. And for a startup, development speed is so critical. So we ran with this idea for a few years. It didn't really grow as we wanted. So we started looking at alternatives of what to do. And this is how I ended up at Dropbox. They acquired the app, the team, and I joined Dropbox 2 years ago. So today I work on Dropbox. When I joined, I went to the iOS team. And immediately I was surrounded by super smart, super experienced iOS engineers. And this new environment allowed me to learn many new things. And I decided, this time I'm going to figure out testing. So a year ago, I was given the opportunity to work on it full time. And today I'm leading a team that's focusing on figuring out and building UI testing for the rest of product engineers at Dropbox. So what this means is that we're thinking a lot about how to reduce friction for any given engineer at the company to come in and add a test for the feature that they're building. This team actually does this for iOS and Android, but I'm going to be talking about the iOS side. So, but when building a system to do testing at Dropbox, what I was really focusing on is I wanted to build something that would work for me and that would have worked for the previous apps. So what I'm going to walk you through is how to build up a system of tests. And this is something that I really wish I had when I built my previous apps. It also happens to scale up pretty well to Dropbox, but this should work really well if you're a team of 1, 2, 3 engineers working on an app. So let me show you kind of how we arrived at things and what we're working on today. So when this team was formed, we had one big assertion that we made, and that is UI tests are awesome. You might be more familiar with unit tests. And unit tests are pretty good. They allow you to test a small part of the code. It's good to test like one module, but they don't tell you if the whole thing fits together. So when your app runs, you can't really, without having a lot of discipline about having unit testing everywhere, you will not get a sense that everything is good. But UI tests, they're very different. They test the app by actually running it and running through a few product flows. So they give you quite a bit of value. So these are some of the fun reasons why UI tests are great. So UI tests, they document how a feature is supposed to behave. So when you write a UI test, you're writing a flow for a feature. So you pick up a feature and you say, the feature has 2 or 3 different flows within it. And you will write a test for one of these flows. So in the process, you end up documenting how your app is supposed to work, how your product is supposed to be working, not simply how the code fits together. And you end up covering a very large portion of your app. So as part of the UI test, you will end up maybe logging into your app, you test your UI navigation, you end up testing your networking, your databases. So with even having one test that runs and succeeds, you have a sense that your app is not completely broken, it doesn't crash on launch. It's a really nice signal. You get a lot of value with very few tests. And they also, when you have UI tests, you end up with easier refactors. So when you do complicated changes that have side effects, you often don't know if you broke something. But because UI tests cover such a huge area of the app, they allow you to make refactors faster. They allow you to move along faster and know that likely you didn't break things. So this is really the assertion we started with. We do have unit tests in the Dropbox app, and they're being used. But we wanted to provide a lot of new value to engineers and minimize kind of the effort and the effort and the amount of training that they would have to do to use our system. So we thought, OK, great. We want to do UI tests. Let's add them into the app. And this is what happened. So what we decided to do is we're going to ship a framework. We're going to connect it to our testing systems at the company. And we're going to just build something. And if you build it, they will come. Like, that was the idea. So we built something. And what ended up happening is that engineers did look at the system and thought, great, I can now write tests. They came in and they wrote tests. And that was great. We thought, success. So we started looking at these tests. And there were a few problems. It wasn't great. First of all, there was a lot of repeated code all over the place. So with the UI tests as they were written, each test was pretty much a script of like, oh, find this button, find this text field, do something with it. It was a lot of code to do even the simplest thing. And a lot of repeated code, test between different test cases. And these test cases were large. It took 20, 30 lines of code to do even simple things. The issues that really started happening were a few weeks later, the product actually changed. So the Dropbox app would get changed. We would have some new flow. We'd rearrange a few things. And tests would start breaking because you have to kind of keep your tests up to date with your product. And that would be fine, but the way that the tests were written just wasn't great because of all of this repeated code. So if you broke something by introducing a new flow or by renaming a button, it was very difficult to figure out all the tests that were using it. So this wasn't great. And we ended up with a lot of flaky tests. And everyone was frustrated. Engineers had a lot of red tests, so they weren't happy. And my team, we were exhausted because always we would go and try to fix tests and chase down the engineer and tell them like, oh, come on, you can edit your tests, you can fix things. It was just frustrating. It was not great. So what we decided to do is, okay, let's take a step back and see where we are. So we started to try and find a way to organize our tests. And as we were going through this exercise, the whole team realized that we were rebuilding a lot of very basic software engineering principles by just trying to reorganize the tests. So instead, what if we stood back and built an actual software product? Like, what if we built a product for our testing system? And this is what we did. So what does it mean to build a software product? Well, for me, it's fairly simple. It means to build a system that's architected, it's organized, it's intentional. So you're building something with thought put out in it. It's modular, so you have code reuse, you have modules connecting together. It's looking closer to your app instead of a script. And a software product should have rules and should have conventions, because rules and conventions make it easy for everyone else to work on it. It also makes it easy for you to work on this system, because if you haven't used it in a while, you can come back to your tests and you remember the set of rules you use to write new tests. So you don't have to sit there trying to remember, oh, how do I write a new test? But most importantly, if you're going to have a product, you have to have a customer. Like, you are trying to build something that someone wants to use. And in this case, for tests at Dropbox, what we had was the customer was the mobile engineer, the product engineer, that what they wanted to do was build a feature and also write a test for it. So we sat down and tried to build a really good system for them to use. So are your tests a software product today? So actually, before I jump to that, this is a quick little hand-drawn thing that I had. This is kind of how our tests look like before this transition. So you had test code, you had UI code, and it just kind of all connected together. It was jumble. And in the software product, it ends up being closer to this. You still have your test code, you still have some complexity, but as you start organizing things, your code flows in a much more cleaner way. And this will start making more sense in a minute. So likely, your tests today are not a software product. And in my experience, here are some of the common reasons why this happens. So test code is kind of internal code. You don't actually ship it. So the quality bar is just lower. And that kind of makes sense. It's also built quickly at the end of a project. Unless you have a lot of foresight, you decide that, okay, at the end I should add a few tests. And you're running out of time, so it's kind of an afterthought. And if a test passes, it has to be good. So this is kind of a tricky one, but as you're starting to write a test, once it takes you through the flow that you want, you'll get this green check mark saying the test passes. And you think, awesome, I'm done, I can move on because something gave me a green check mark. We're used to that from school. Like, check mark means good. So this was, this means like you don't have to pay attention to the quality of the test because if it passes, it's good. But I think that's actually really the wrong way to think about it. But this gives you kind of a sense, a false hope that things are good. So let me show you how to make things better. So this is the app model architecture that we came up with at Dropbox. And don't let the term architecture here scare you. Like, this is not complicated. We're calling it architecture just because it has rules, it's thought out, it has conventions. But really just something that's organized in a very specific way. In this case, there are 3 layers of abstraction. You don't have to remember this yet. We'll go through each one of them. But you have your test cases at the very top, you have some code in the middle, you have this other thin UI driver, and then you connect to your app. So throughout the rest of my presentation, I'm going to be using Swift and XCUI tests. But really, this methodology to organize your tests applies anywhere. So if you already have unit tests that are using Appium, using KIF, using any of the other technologies available, this is still very applicable. Because this is a pretty generic way to organize UI tests. So let's start with the test cases layer. So the test cases layer is the very top layer. And it really describes those product flows. It describes what your product should be doing. And in the test cases layer, ideally, the code that you have should be very much like plain English. Like a non-technical person should be able to look at your test case and understand what's going on. And you should not have any detailed code here. You shouldn't be finding some specific button in a specific text field and doing something with it. This should be like very readable, high level, like my app starts and it does a few of these actions, and that's what I'm testing. And here are the rules that I have for the test cases. So I organize my test cases by feature area or by screen, and this is pretty common. Just keep similar tests for the same feature together. Do split it up into a few files. But this is very important. Each test should begin in a very well-defined state. So whenever you're reading a test case, you should know that at the very first line, you need to know where your app is. And for most apps, I would recommend having only like 2 starting states. Typically, this is a logged out state or logged in with some specific test user. Complicating it further than that just makes it very complicated for you to see a test and know how it will progress, know how it will start. And in the test cases layer, you should only be using app model actions. So this test cases layer will only be using calls to the next most important app model layer. So this is a very, very high level type of test code. And you should avoid local helpers in your test cases. So if you're finding that you have a bunch of test cases that you wrote and you have a local helper to help you do something, typically you can turn that into an app model method that will help other test cases or other features. So this is how a test case could look like. So imagine that you're testing a messaging app. In this messaging app, you log in, you end up on the messages screen, and there's a button to open up stickers and send a sticker. So we wanted to test sending a sticker. In this case, I inherit from a logged-in test case, which gives me a starting point that I am starting this test right after a login with my test user. Then what it does, it verifies that we are on the messaging screen. So this kind of verifies the starting state just in case. Then you open up a sticker screen, send the first sticker. This is useful to have comments here that, oh, we're assuming that the stickers will auto-close and that you'll be back to the messages screen. And then this verifies that stickers are sent. So this is super simple, very readable. If you think about it, like if you show this to a non-technical person, likely they can figure out kind of step-by-step what it's trying to do. But what do the actual app model pieces look like? So the app model pieces, they describe how to actually interact with the feature. This is where code specific to your UI comes in. This is where you say, this is what a button should be named, or this is how to find a text field. So you should think about your app model as really an API to your app. So any flow that a customer can go and take through your app could be an app model step. So this is you're modeling your product as an API. You're not trying to model the code that you wrote to create your app, but you're modeling what the app actually does, what services it provides, what features it has, how they connect together. And there are a few rules here. So once again, you should organize it by feature, or I like organizing by screen. Kind of like every view controller would often have kind of an app model area connected to it. And it only uses other app model methods or the UI driver. So what this means in practice is, imagine you're trying to model a login. So as part of a login, you have a function that will say, take in a username and password and log you into your app. That can use other steps. It will say, fill in a username with this value, fill in the password with this value, and submit the login form. So those three actions are also app model steps. But they, the login itself uses kind of the high-level compound function that combines the three low-level app model functions. This will make sense in a second. But pretty much what happens is that the low-level specific steps will end up using the UI driver, and they will end up going to your UI and doing something. And these compound steps aggregate other app model actions. And I think it's important to not keep any state in your app model. And in general, don't try to keep states within your tests. Try to avoid if statements. Try to be very clear with the flow of, if I'm going to test a feature, it's going to go from start to finish, and these are the exact steps to take. And it makes it much easier to reason about. So when you read test code, you kind of know that every time you call a function, it will try to do the same thing. So here's how some app model steps could look like. So in this case, I have an app model that has two screens. It has a messages screen and a stickers screen. And this matches to a set of steps that they provide. So my app provides an API to my messages screen and an API to my stickers screen. There's a reference to the UI driver here. And there are two methods that I'm showing. One is to verify that you're on the messages screen. So this goes straight to the UI driver. This actually talks to the app and gets the current title of the navbar, make sure it equals to messages. But then there's a compound step to open up the stickers. And that first verifies that you're on the right screen, and then also does a UI driver step to actually open the stickers. So now for the UI driver itself, which is kind of critical if you're going to be building this. So what the UI driver does is, this is the layer that will actually interact with your app. So this is what actually emulates the touch gestures as part of your test to do actions. And it also allows you to query back and get information about the state of your app to make sure that after your test is run, you're in a good spot. So for the UI driver, the way I organize it is by UI component. So this means that you're usually mapping different UIKit elements that are available. So mapping your buttons, your navigation bars, your table views to very thin UI driver layers. So you're providing kind of a simplified API to the kind of UI elements that you can access within your app. The UI driver pieces should be very imperative, and they should be failing fast. So this is code that you would be writing that's very optimistic. What ends up happening is that you're going to be calling some UI action of saying, get a button, give me back this reference to a button, and I'm going to tap it. You don't want optionals. You don't want to have if statements. if that fails, you want to be failing fast at that point and getting just the button. So yeah, it's very important to kind of assert as soon as something fails. And that way, that avoids logic all over the place to figure out, oh, does that button exist? Or if it doesn't, your test case should know what it's doing. So the buttons should be there. And if it's not, you should be failing fast so that it's easier to debug where things broke. And this really helps keeping your debugging time down. So one last note is that I don't recommend using your actual test framework. So if you use XCUI tests or if you use Appium or KIF or anything else, don't use it as a UI driver layer. Still write something very thin to simplify the real framework. Because the test frameworks today are pretty heavy. They give you a lot of things. They give you a lot of optional values that are returned. So you really want to simplify that. So in practice, it would look something like this. You have a reference to your XCUI application. And then you have, in this case, two things. You have an app model layer for the navbar, and you have an app model layer for your buttons. And for this, you give an app reference to each one of them, so that when you call something on this UI driver, you can actually go to your app and you can drive the UI, or you can query the app for some information. So you would initialize it like this, and then you can implement the specific actions. So all navbars provide a service for you to get its current title. And this has the messy code of interacting with XCUI tests, of getting the top navbar, getting its identifier, and returning it as a string. Now, in the second example of getting a button by title, this is where I actually try to fail fast. So XCUI tests has this little property where if you're going to get a button with a specific title, it gives you back a query object. And this query object, it's not a real reference to this button. Only when you go to use it for something will it fail to find the button. So in this case, I'm checking that the button actually exists and failing immediately, because that will run that query. It will actually try to find the button. And if the button is not there, it will fail. Otherwise, once that passes, you return the button, and you can call tap on it and use it. So in a nutshell, this is the app model. So you start with your test cases, which is super high-level readable code. Then you implement the different actions that your app can take in the middle layer, which is the app model itself. And then you have a very thin UI driver layer that simplifies the test framework that you have. And the biggest advantage of this is that it becomes very cheap to add a new test. So when you finish a feature, it's very, very cheap to go in and add a test, because most of the actions that you will need are already done in the app model, and you will just have to implement something small. And honestly, like at Dropbox, without this, we'd be in a really bad spot. So what we ended up doing is we went from these huge scripts of 20, 30 lines of code to a software package that has structure. It has simple, easy-to-read test cases for everyone to use. It has this nice layer in between, and a UI driver layer that we maintain as a platform team. So that way, your end users, the final engineers that are using this, mostly only have to care about the top two layers. And you almost never touch the UI driver once you invest some time in building it. And I promise you, like this takes a few hours to set up. It's not super simple, but the investment is really worth it. It will end up saving you time incredibly quickly. So this approach will pay off once you have released a few app updates. Once you go to build a new feature and test it, it really pays off to have the structure set up. It makes it easier for you to go back to it and write new tests. So this is the app model architecture. And I hope this helps you in your current app or in the next app that you're going to be building. And before I end, I really want to thank my team at Dropbox. We're a small team, and they're incredible. Like we came up with the system, we prototyped a lot, and I wouldn't have the stock without them. And really, like, this took a lot of prototyping, a lot of trial and error. So it was expensive. It was very expensive to get to 100 tests and have to go back and refactor everything into a structure. So hopefully this saves you some time. Like, this is a good approach to start. It's much better than having scripts. It might not be like the optimal UI testing system that will scale to thousands of people, but it scales well enough to a few dozen engineers working on things. It scales pretty well if you have you working or one or two people. So yeah, this is it. Thanks so much. And
Thank you, Michael. Any questions? We'll be taking one or two.
Hello, my name is Joel. I have two questions. One is that, do you recommend test-driven development whereby...
actually, can you speak up just a tiny bit?
Do you recommend test-driven development whereby you write tests before development? And my second question is, how much of a percentage of test coverage do you recommend?
Okay, so there are two questions. Do I recommend test-driven development, and how, what percentage test coverage to aim for? So test-driven development is tricky. It takes a lot of discipline up front to really do it well. So in practice, it doesn't. I haven't seen it consistently work. So with this approach, we're not really trying to advocate for any specific development approach. Any engineer can choose how they do things. A team can choose to do test-driven development. Really, the idea is to just get some test coverage to make sure that your app fits together. So test-driven development kind of forces you into a very specific way of working. And if you can get yourself there, I think you'll be in a good spot. But in most cases, you're running against deadlines, you're trying to ship. So often, you won't do it as much. As far as test coverage, we don't try to measure test coverage too much. We just let every team figure out how much testing they need to do. The more testing they do, the less bugs they have, the less time they can work on new features instead of improving things. Yeah.
Okay, thank you.
Thanks.
Okay, thank you. If you all have any questions for Michael, you can catch him during lunchtime. And Michael, thank you.
Thanks.